Hello, everyone. Good to see you. Today is going to be a reasonably relaxed session. Probably take less than an hour and a half, so probably finish around 7 today. So let's get on with it. I've got some questions prepared for you. They are of various levels of difficulty. We'll start with some easy ones, and at the end we'll do two problems, two word problems. Okay. So we'll start with the reasonably easy ones. Problem one: you have a system of equations. It's a nonlinear system. Does anyone have any ideas on how can we do that? How can we approach this? Maybe anything you notice about it. Maybe some special property. So maybe something special that will, well, not necessarily it will help you solve it, but it's worth noting. Well, one very important property of this system is that it's symmetrical. It's a symmetrical system. Symmetrical. X square root y. If you put the second equation into a surd, then you get the same surds as the left-hand side of the first one. You mean take the square root? Yes. Fair enough. Fair enough. Ah, very good, Vishaka. Yes, you're right on the money. Let me just finish explaining what the symmetry is about. Symmetrical system. Well, if you switch x and y round, you get the same system. Change x and y, and you get y square root x plus x square root y equals 6, and y squared x plus y plus x squared y equals 20. It's the same thing. It's identical. Change x and you get an identical system. What does that mean? Well, this means that if AB is a solution, then BA is also a solution. Okay. Not that it will particularly help you solve it, but it's just a useful property. In some systems, it will help you. It will help you solve it. Yeah, you square the first equation. So square the first equation, and what do you get? You get x square root y plus y square root x squared equals 36. So that's x squared y plus 2 x square root y square root x plus y squared x equals 36. And somebody's noticed that this part is equal to 20 because it's already given us. This is 20. So we have 20 20 20 plus 2. Now this is xy square root xy equals 36. And that means xy square root xy is equal to, well, 2 is equal to 16, but without the 2 is going to be 8. So from here, what can you do? Well, you can square both sides. Yeah, you get x squared y squared xy equals 64. And then you get x cubed y cubed is 64. Xy cubed is 64. And that means that xy is 4. Because if something cubed is 64, then can you link last webinar's Miro board? So here's the Miro board. It has, this is the last week's webinar. It's here. Okay, so we have got xy equals 4. What else do we have? Well, let's take the second equation and try to do something with it. So the second equation, and we can write that x squared y plus y squared x equals 20. We can factorize the left-hand side. So we get xy, open bracket, x plus y equals 20. But we know that xy is 4. So that's 4 times x plus y is 20. 4 times x plus y is 20. And that gives us x plus y is 5. So you get x plus y is 5, xy is 4. These are you can guess. This is very similar to Vieta's theorem. It's very easy to guess that is x equals 1 and y equals 4. But also, remember what we discussed about the symmetrical, about the symmetry. Also, x equals 4 and y equals 1. How can you prove that there are no more solutions? Well, if you substitute from here to prove no more solutions, we can express y equals 4 divided by x, sub that in, so x plus 4 over x equals 5, multiplied both sides by x squared plus 4 equals 5x. This is a quadratic equation, and a quadratic equation can only have 2 solutions, up to 2 solutions, okay? It's a quadratic, hence no more than 2 solutions. And we found them. We found both of them, right? So this is an extra step. I mean, you don't need to explain every time because, I mean, it is obvious because it's implied that you will have a quadratic. But it is worth noting. I mean, always ask yourself, could there be more solutions? We'll get to a question where this solution is incredibly easy to find, but then trying to prove other solutions. That's what gets you. That's what gets you. Okay. Any questions? Any questions here? Okay. All right, problem 2. Now, this is a double substitution. Can you see it? You see the double substitution? Can somebody help me? Yes, Parachita, very good. Absolutely. So let's do, I'll just use U and V. It just, I'm more used to using U and V. U is equal to X plus Y. And V is equal to X over Y. And you can see that the equation becomes U plus V equals 9. And then you have U multiplied by V equals 20. This is a very familiar situation where you have adding makes one number and multiplying makes another. You can only have up to 2 solutions because you will get a quadratic equation. And can you guess them? 5 and 4, of course. U equals 5, V equals 4. And because this is a symmetrical system as well, then U equals 4, V equals 5. I'm using the symbol OR. Okay, so from here, I can say, well, if U is 5, that means X plus Y is 5, X over Y is 4. So from here, X equals 4Y, X equals 4Y, X plus 4Y, 4Y plus Y equals 5. And that means that Y is 1 and X is 4. Or X plus Y is 1, X over Y is 5. Why am I saying it's 4? Well, X plus Y is 4, X over Y. That means X is 5Y. So 5Y plus Y is 4. And that means that Y is 4 over 6, that's 2/3. And X is equal to 10/3. Okay, and that's the answer. Or 1, or 1, and 10/3, 2/3. Now this is a symmetrical system, but this is not. The original one is not symmetrical. Therefore, you don't have a symmetrical answer, symmetrical solution. But U and V are symmetrical. U and V are symmetrical solutions, but X and Y are not. Okay. Any questions here? On a scale of 0 to 10, would you be able to do this exact question? If I close the solution and give this question to you, would you be able to solve it right now? On a scale of 0 to 10, what's your confidence? Perfect. Well, 2 people haven't replied, but I'm assuming somewhere somewhere similar. Problem 3. Well, it doesn't look like you can do a substitution here, or can you? You could potentially do a substitution. You could do u is equal to x over y, and that becomes so the first equation becomes u minus 1 over u equals 5 over 6, and this is a quadratic equation. You can find u. I'm going to do a different method. Possible substitution. I'm going to go a different method. I'm going to take the first equation and I'm going to simplify it, or rather complicate it slightly. I'm going to find the common denominator for the first one, and the common denominator is of course xy, and I multiply this by x and multiply this by y, so I get x squared minus y squared equals 5 over 6. What a coincidence, because we already know that x squared minus y squared is 5. So we sub that in, so it's going to be 5 over xy equals 5 over 6. 5 cancels, and we get xy, of course, is equal to 6. Interesting. That's the first equation. The other equation that we can use, well, x squared minus y squared equals 5. It's unavoidable. X squared minus y squared equals 5. We could potentially guess the solution, but you can't be sure how many solutions you will have. So rather than guessing, I'm going to make y the subject, and I'm going to use substitution. 6 over x, and I'll sub that into the second one. So that goes in, and what I get is x squared minus 6 over x squared equals 5. Okay, so I'll open the brackets. X squared minus 36 over x squared equals 5. What I need to do is I need to multiply everything by x squared. That's why I don't like cross. When you multiply the dot, because you use x so often. That's use x so often that you get confused. Is it x or is it multiplication? So it's going to be x to the power 4 minus 36. Actually, most of the rest of the world uses dot for multiplication. 5x squared. So x to the power 4 minus 5x squared minus 36 is 0. 0. Okay, so this is a quadratic equation. Well, it's a quartic equation, but a simple substitution makes it quadratic. I hope you see that. And you have the solution. I won't bore you with. I'm going to factorize it. It's going to be x squared minus 9 x squared plus 4 equals 0. Because its multiplication is minus 36 and adding makes it minus 5, so minus 9 and 4. I can factor this bit, x minus 3, x plus 3. This is a difference of two squares formula. And this one is squared plus 4 equals 0. This thing cannot be equal to 0 because it's a positive It's positive. So either x minus 3 is 0, or x plus 3 is 0, or x squared plus 4 is 0, which it isn't. Because x squared is a positive number, plus 4 makes it positive. A positive number cannot equal to 0. That's not possible. So x, no, there are no solutions here. X equals minus 3, x equals 3. We'll call it x1, we call it x2, and then we can find y1. It's 6 over x, which is 2, and y2 is going to be 6 over minus 3 equals minus 2. Interesting. I think I got a different solution here. Oh no, that's fine. Yeah. So the answer, I did make a mistake when I was preparing, but now I haven't. I've corrected myself. Answer is 3, 2, or minus 3, minus 2. Nice. Any questions? Am I going too fast? Or okay? Type okay or fast. Definitely not too fast. Okay, not too fast. So it might be even slow. Okay. Now, next one. Could you solve it in your head? Like, real quick. Like half an hour ago, I gave this problem to my brother-in-law. He just finished university recently. He gave me an answer right away. But yeah, all ones, of course. All ones, because if everything is 1, it makes perfect sense, right? So 1, 1, 1 is a solution. The problem is, how do you prove that there are no more solutions? Or how do you find the rest? How do you find the other solutions? Right? Because it's easy to find one solution, but when it's a nonlinear equation, the problem is to find the other ones. Well, there's no magical recipe here. You just good old substitution. So from the third equation, no, there's one more solution actually. There's one more solution which is not obvious. So from the third equation, you can express z is equal to 2 minus xy, and sub that into 1 and 2. Sub into 1, and you get x plus y 2 minus xy equals 2, and sub into 2, you get y plus 2 minus xy multiplied by x equals 2. Now, so now you have you effectively have 2 equations with 2 unknowns, which you can solve. So 2 equations two unknowns. So we'll open the brackets. So x plus 2y minus xy squared equals to 2. Y plus 2x minus x squared y equals to 2. I'm guessing subtract. Do this minus this. Okay. And actually, no, the other way around. Really doesn't matter which way I go, but I think this is going to be just slightly prettier. So it's x minus y plus 2y minus 2x minus xy squared plus x squared y equals 0. So what do I get? I get y minus x. Now here, I can factor out xy. It's going to be plus xy minus y plus x. 3, 1, and minus 1. Mark. 3, 1, and minus 1. 3, 1, and minus 1. So let's check the last one. So minus 1 plus 3 equals 2. That works. What about this one? 1 minus 3 is 2. No, that doesn't work. Good try, but no, unfortunately it doesn't. Besides, you can see that it's a symmetrical system. Right? It's a symmetrical system because you can change x, y, and z around, and the system will not change. Therefore, it's a symmetrical system. Therefore, if A, B, C is a solution, so is A, C, B, and B, A, C. Oh, there's 6 of them. There's 6. So if you find a solution, all 6 permutations will be solutions as well. BCA, CAB, CBA. Oh, I thought there was only 3. No, but there's 6. So yeah, if you manage to find a solution, then all the permutations of that solution will also be a solution because of the symmetrical nature of the system. Okay. Coming back to this. So what I've done is I've found the like terms, of course, here. So it's going to be y minus x. Now here, from these two, I've taken out xy as a common factor, and I'm left with minus y plus x. And you can actually see that y minus x is a common factor here, because if I switch that round, equals 0, I can write y minus x plus xy, y minus x, and I'm changing this to a minus. Hope you can see it. And now you can see that these two have a common factor, y minus x. So it's going to be y minus x, open bracket, 1 minus xy equals 0. Interesting. Okay, well, never mind. Yes. So you have either y minus x equals 0, or you have 1 minus xy equals 0. So either y is equal to x, or xy is equal to 1. If xy is equal to 1, then z is equal to 2 minus xy is equal to 1. Xy and y. So from the second equation, we can take y plus zx equals to 2, and from here we can say that y equals 1 over x. No, x is equal to 1 over y. X is equal to 1 over y. And we have y plus z, which is z is 1, multiplied by 1 over y is equal to 2. Nice. And from here we can multiply, so y squared plus 1 equals 2y. Y squared minus 2y plus 1 equals 0. Y minus 1 squared. This is a perfect square, equals 1. So y equals 1. And that means x is also equal to 1. So we got a solution. We got solution number 1. So z equals 1 here. So we found it. We found one of the solutions. What about this one? Well, y is equal to x. Okay, we sub that in. Can you hear me now? Can you hear me well? Oh, yeah, okay. How do you tell if a symmetrical equation? Let me finish this. I'm using a slightly different method from the one I've prepared for you. So, okay, so x plus xz. So we can sub that in. We can do x plus x multiplied by 2 minus x squared equals 2. X plus 2x minus x cubed equals to 2. 3x minus x cubed is equal to 2. Oh, that's not pretty. X cubed minus 3x plus 2 equals 0. Okay, to solve this, you need to know how to solve cubic equations. let's be creative here. Okay, what I did is I found that y equals x. I substituted that into the third equation. Then I used the first equation. Then I use the second equation. So we're talking about 1, 2, and 3. Is the second equation. Now I found myself where I need to solve this cubic equation. 3x plus 2. Vishaka, answering your question, yes. If a person is holding, so the Vishaka is asking a question: is if a person is in a lift and holding a rope and not pulling himself up or herself up, that means the acceleration is 0, of course. If you're stationary, acceleration is 0. Now, x cubed minus, let's say we don't know how to solve this. Of course, you can divide polynomials, and they will teach you in A level how to do this. But what we can do is we can solve graphically. Vishaka, yes, in this context, yes. Holding means stationary. 3x minus 2. This is a we can solve this graphically. We draw the curves. So the cubic curve is going to be 1, 1, 2, 8, 2, 8, and 2, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be like this. And then 3x minus 2. So the intercept is minus 2, and it has 3. So it's going to go like this. 3. Interesting. 3, 1, 2, 3, 1. Oh, interesting. It goes through this point. So graphically, I can see that x is minus 2, x is 1, and the third solution, well, it's between 1 and 2. It's between 1 and 2. And x equals minus 2, x2 equals 1. We already have this solution, so we don't need that. And x3 is question mark between 1 and 2. Difficult problems in the assignment. Yes, let's do that. And sorry, I think I trapped myself. There shouldn't be a third solution. I must be in trouble here. How could it be? I'll just double check. Equation 4. So it's 1, 0, minus 3, 2, minus 2, 1, minus 2 and 1. Okay, I'll x cubed y equals x cubed. Y equals x cubed. Of course, that's so silly of me. And y equals 3x minus 2. Yes, you can see that there are only 2 points of intersection, and one is here. It's a tangency point, and minus 2. So I've misdrawn my graph. There we are. Okay, we have 2 solutions. Second one is minus 2, and then very easily we can find that x is so x1 is, well, x is minus 2. Minus 2. And that means that y is also minus 2 and z is also minus 2. Very easy to show. That's the second solution. So answer, we have 1, 1, 1, and minus 2, minus 2, minus 2. Okay. And problems. Okay. A team of workers has completed a certain task. So these are mathematical workers, so they are identical. They do exactly the same amount of work per unit time. A team of workers has completed a certain task. All right, so I don't know what they were doing. Painting a fence, perhaps, like Tom Sawyer. So this is a task. So some work. And a team worked so many days. Okay. So let's say it is X people, and it took them Y days to complete. An identical task can be completed by 20 fewer people, so X minus 20 people. It will take 5 days longer. It will take Y plus 5 days. And thirdly, if you have a bigger team, so if you have 15 people, it will take them 2 days less, so Y minus 2 days. How large was the team and how many days did they take? So find X and Y effectively. That's how you do it. That's how you do this problem. Okay, so let's have a look. So what do we have? X people, Y days, X minus 20 people, Y days. X cubed is, yeah, doesn't work. Tasks There's some work needs to be completed. Okay. Well, let's define the amount of work. How do we measure amount of work? Work is usually measured in worker hours. What is work? In physics, of course, work is force times distance. But when you're talking about people, work is people multiplied by time. Because what do we mean by people? Well, a person, the productivity of a person, is how much work they can do in a given time. So productivity. Basically, it's their power. It's the power to do work. So the work is productivity multiplied by time. So if we take the standard productivity of one person, we can replace the word productivity with person. So work is a number of people multiplied by time. That's how we measure work in a workplace. Usually it's people hours. So commonly used terms. People hours. Worker hours. Sorry, worker hours. Worker days. Worker years sometimes. Yeah, worker years. I don't think we ever use kilo worker days. But yeah, if you have a certain project and you need 1,000 people to work for 1 hour, or you can have 100 people working for 10 hours doing the same amount of work, right? So hope you get a feeling for what we're talking about. So the amount of work, the task is how much work has been done. In this case, it is xy. Work done is xy. And here, x minus 20 multiplied by y minus 5, y plus 5. And here, it's x plus 15 multiplied by y minus 2. This is the amount of work done in each case, but the work done is the same because the amount of the certain task is the same amount of work. Therefore, the equation looks like this: xy equals x minus 20 y plus 5 equals x plus 15 y minus 2. You can write this out as xy equals x minus, well, let's open the bracket. Xy minus 5x minus 20y minus 100. And you can take the first and third. So first and second. And now you can take first equals third. Take the first and third. So that's xy is equal to xy minus 2x plus 15y minus 30. So in both cases, xy cancels, and we have 5x plus 20y equals 100. And here we have 2x minus 15y equals minus 30. Divide by 5, x plus 4y equals 20. 2x minus 15y equals minus 30. I'd say multiply this by 2 and subtract. So by elimination, so 2x plus 8y equals 40. So times this by 2. I write down this one, minus 15y equals minus 30. Subtract them from each other, and you get 23y equals 40 plus 30, so it's 70. Doesn't sound right. What went wrong? Yes, so this is plus 5. So that makes it minus 5, minus x, minus 2. So we are adding, we're not subtracting, we're adding. And that's going to be minus 7. Minus 7y equals 10. Still doesn't make any sense. Equals minus. I'm very sorry. This is minus 70. Yes. And then y is 10. Okay. And x, we can find x. X is minus 20 minus, well, 20 plus 4y, and that is 20 plus 60 equals 20 plus 40, sorry, 20 plus 40 equals 60. So answer, we had 60 people and 10 days. 60 people worked for 10 days. How do you find this problem? Would you be able to solve this right now on a scale of 0 to 10, please? Would you be able to solve this exact problem if I gave it to you on a scale of 0 to 10? Okay. Is that because I messed up here with the signs? Made quite a few mistakes here, but okay. Next one. Find all 3-digit numbers such that the first digit is 3 times less than the sum of the other two. The difference between the number and the same number with the last 2 digits switched place is non-negative and divisible by 81. An interesting task. So you have a 3-digit number. If you did like interesting questions on Python, question 14 in the assignment. Let me have a look. Maths 1006. Wait, is it 1007? Oh no, 1006. Question 14. Yeah, absolutely. That's a very similar method, of course. That's why I gave you this problem. 3-digit natural numbers. Well, that's interesting because how do you get the numbers? Well, you have the first, find all 3-digit natural numbers. So let's say A, B, C is a 3-digit number. And let's call it X is equal to ABC. Let's say example X is 342. But that means, because 3 means 300, so it's 3 times 100 plus 4 times 10 plus 2. So we can write X as 3 is 100A plus 10B plus C. Okay. And the first 3 digits, the first 3 digit is 3 times less than the sum of the other two. The first digit, so A, is 3 times less than the sum of the other two. So A is B plus C divided by 3. The difference between the number, so X minus the same number with the last 2 digits switched place. So that means X minus let's call it X star is equal to X star. So switch place is going to be 100. So X star is ACB. That means 100A plus 10C plus B. So X minus X star is divisible by 81 is equal to 81N. Right. There's a lot of stuff here. Let's start cleaning things up. Well, first of all, we'll sub that in, X minus X star. So that's 100A plus 10B plus C minus 100A minus 10C minus B is equal to 81N. Well, 100A cancels, and we get 9B minus 9C is 81N, and B minus C equals 9N. Basically what it says that the difference between B and C is B minus C can be Well, it can't be 0 because it says B minus C. Wait, what does it say? That is non-negative. Ah, okay. So B minus C can be 0, or it could be 9. Can't be anything else. With 0, 9. So we have B minus C equals 0, or B minus C equals 9. There's two possibilities. Then what do we have? We have A equals B plus C over 3. And A equals B plus C over 3. And of course, we know that A, B, and C are less than or equal to 9, greater or equal to 0. And of course, A is not equal to 0. So, yeah. And the same thing here. I'm just a bit lazy now. So 0, A, B, and C, they're all less than 0. A is not equal to 0. Nice. So what can we do here? Well, it's very important to understand that there's also they are natural numbers, of course. A, B, and C are natural numbers. So A, B, and C are natural numbers. A, B, and C are natural numbers. That means they can only be whole numbers, whole positive numbers. Well, let's see what we can do. Well, from here, we can write that B is equal to C, and A is equal to B plus C over 3, which is 2B over 3. That means that 2B equals 3A. 2B equals 3A. What are the possibilities? Possibilities. T's. If A is 1, that's not possible. A is 2, then B is 3. A is 2, B is 3. A is 3, not possible. A is 4. Then we have 12, then B is 6. A is 6. Well, 5 not possible. A is 6. B is if A is 6, B 18, 9. Okay, so there are 3 possibilities. And C, we already know that C is equal to B. So C is 3, C is 6, and C is 9. So we have 3 numbers, 233, 466, 699. Those are the 3 numbers. So X is. Okay. From here, B minus C equals 9. Well, there are very few possibilities here because it's either 9 minus 0 is 9 and nothing else. 8 minus 1, no. No, that's the only possibility. So B equals 9, C equals 0. And that means A is 3. So it's 390. So these are the 4 numbers. And I just will double check because sometimes I get things wrong. 233, 390, 466, and 699. Yeah. So this is how you do it. Now, one more thing that I would recommend you doing as future really successful people in any field of life that you choose, likely, and so that you I really advise you to learn programming language. Doesn't really matter which one, but programming is a really powerful tool. It you become a very employable person. Yeah, so a person who can do maths and do programming and physics. That's really valuable. Probably one of the easiest languages that you can learn is Python. I might have mentioned that. I've myself when I realized I want to learn Python, I just went to this website, practicepython.org. It's a free website, and I did all of these, and I learned Python in probably like a week. But because it took me a week because I know other languages of programming, so it might take you a little longer if you haven't. But these are really interesting place to practice Python. Now, what I wanted to do is I wanted to do the same problem, but wanted to do the same problem, but on Python. So, what would you rather? Me going through? Okay. Would you like to see this problem done in Python? Or would you rather, okay, yes, please. Or would you rather me spend more time going through tricky problems? We got one, yes, please. Anyone else? Would you like to see tricky problems? No, tricky problems. We can do both. We can do both. All right, I'll try to do this for really quickly on Python. So online Python Python. Okay. So what I want to do is I want to go through all the 3-digit numbers, right? So for I in range, for all the 3-digit numbers from starting from 100 to 999. Let's just check that it works. Print I. Okay, run the program. It goes up to 998, so it's not including 99. Okay, starting with 100, so up to 1000. Okay, right. Now we need to get the digits. Getting the digits in Python is quite interesting. So what you need to do to get the first digit, A, is I, the number, and divided by 100. Okay. Print A. Oh, that's the divide by 100. Divide by 100. So that gives you the first digit. I'll just go up to 200 for now, just to 100 to 110. Okay, run. So it gives me the first digit, print A. B, the second digit, is equal to I percent 100 and print B. Percent 100 and then divided by 10. That's the second digit. Let's check that it is correct. Print B. Yep, the second digit is indeed 0. And C, the third digit, is I percent 10. Easy. Okay, and now we need to check if B plus C is equal to 3A, 3 times A, and what was the other one? And B minus C, wait, B minus C is 9. B minus C is greater than 0, and B minus C divided by 9 is equal to 0. That means it is a multiple of 9. Then print I. Let's see. Something went wrong. Let's see if I did something wrong. And didn't realize that the debugging would take some time. And integer. Let's see. Of course. What am I? That's so silly of me. I forgot to change that to 1000. What am I doing? Okay. 390. Oh, greater or equal. Greater or equal to 0. Yes, here we are. So here's the code of this problem on Python. Okay, so that's practice. Do give it a go. Okay, so tricky problem. So what can I help you with? Okay, I'm all yours for the next 15 minutes to half hour. Problem 13 maths. Problem 13 maths. Okay. There are two containers. The first contains 100 kilograms and the second contains 2 kilogram acid solution of different concentration. If these solutions are mixed, there is solution contains 70% acid. Okay. Well, you need to understand that this solution always contains the solvent and the dissolved stuff. Example. 200 liters of 21% solution of acid contain 200 kilograms. Let's do it in kilograms. 200 kilograms contain so 42 kilograms of acid and 158 kilograms of water. Okay. Add. So we have 200 kilograms and it's 21% acid, 79% water. So that's 42 kilograms and 158 kilograms. Now, if you add n kilograms of acid of water, so now you will have 158 plus n kilograms of water, and you still have 42 kilograms of acid. And you have 200 plus n kilograms overall, and the new concentration is going to be 42 divided by 200 plus n. So my advice for you just to draw this and see what and see where and try to figure it out. So the concentration is the amount of acid divided by the total mass of the substance. So right here, concentration is the mass of the acid, so 42 divided by the total mass, 200, and that gives you 0.21, which is 21%. Does that make sense? Does that help, Parichita? So there are two containers. The first contains 20 kilograms. So it's 100 kilograms, and this is 20 kilograms. So this will contain 70% acid. So we mix is going to be 120 kilos. And out of this, 72 is going to be acid. So 72% acid. So you can work out the mass. You can work out the mass here. And so that gives you the total mass of the acid. So let's say this is X, this is Y. And yeah, add them. Problem 11 in physics. Problem 11 in physics. Physics 1006. Acceleration of the three masses in the setting shown in diagram. The motion is frictionless and occurs only in the direction parallel to the force and the string. You assume the masses are on a frictionless table and we are looking from above. Okay. Well, you guess. I don't know how to determine whether M2 or M3 will be moving. Well, you don't know, but you assume they are. Assume they are. But oh, it is a frictionless table, so they will be moving. All right. Okay. They certainly will be moving because there's tension in the rope. So because there's tension in the rope, that means 2 will be moving. Because as tension is not 0, 2 will be moving right. Now 3 is attached to a pulley, which is being pulled by 2 ropes. So 3 will be moving left, accelerating left. 1 is being pushed left. Well, that one is obvious. So we'll call this A1. We call this A3. And we call this A2. And then you can use Newton's second law for each one. You can see that M3 is being pulled by 2 tensions. And A1 is being pulled by F and by T into the other direction. So for the first one, it's going to be this F and T. For the second one, it's going to be just T. And for the third one, is going to be T and another T. And that's how you know that they accelerate. It is one rope. But accelerations are not the same, no. They are linked, but they're not the same. Because this is not a stationary pulley, right? It is moving along with M3. And yeah, you can work out the link. You need an equation, linking A1, A2, and A3. You need to use displacement. So imagine, yeah. Imagine 1 moves 1 meter to the left. What happens then? Okay. All right. Problem 9 physics. Problem 9 physics. onto the rope. Find the acceleration of the weights. Well, we don't know which way they will be moving. Let's assume they're moving down. Let's assume this is moving down, this is moving up, this is moving up. Let's call it. Now, of course, they're linked. So if this acceleration is A, this is going to be 2A, and this is going to be 2A. Because this is a movable pulley. And then you just draw the forces. You need to understand that here you have tension 2, and here you have tension 1. It's different ropes, different tension. Hope that helps. Cheetah. Okay. Also, I wanted to clarify, is there a solution for 9 maths? What is the solution for 9 maths? I'm not sure. What do you mean by, is there a solution for 9 maths? Oh, it is a possibility. Like, you can, if there are no solutions, then you just need to prove. You need to prove that there are no solutions. You can. I don't remember the solution to this particular problem, but yeah, I mean, it happens. Yeah, you can have no solutions. It's a possibility. Okay. All right, I'll stop here. Enjoy the rest of the week, and yeah. See you next time. Welcome.